Hi everyone. So in this video, I'm going to show you how to solve first order linear differential equations. So let's dive in. So here is the standard form of a linear first order differential equations. So you can see the equation in this way where you'll have dy dt plus function p of t times y is equal to some other function g of t, or dy dt can be denoted using y prime. Now, how do we solve these kind of equations? Well, we need to look for something called integrating factor, which we're going to label it as mu of t or x, which is equal to the e to the integral of p of t dt. So that's what we call an integrating factor. Using that, we're going to be solving a linear first order differential equations. So let me illustrate the idea using one example I have here. So here's the first equation. So it looks like you have y prime minus 2xy is equal to e to the x squared. So we need to identify what is p of t. So p of t is going to be this function right here. This is p of t. And this function on the right side of the equal sign is going to be g of t. So now that we identified them, let's compute mu of t. So mu of t is going to be e to the integral of p of t dt. So let's substitute p of t. We have e to the integral of, I'm going to pull out the negative 2 and then integrate x dx. So instead of t in this question, our independent variable is x, which is totally fine. So we can actually relabel these p of x and g of x because our independent variable is x. So then if I integrate x dx, I have e to the negative 2 x squared over 2. And of course there is a plus c, but we're going to tag that in at the end of the problem. And then if I simplify this, my mu of t, or in this case it's going to be mu of x, is equal to e to the negative x squared. So that's our mu of x. Now, the idea with this equation is you take the differential equation and multiply both sides by mu of x. So that way you have y prime e to the negative x squared minus 2x e to the negative x squared times y is equal to e to the x squared times e to the negative x squared. So now we clear things up, but keep in mind that this side, the left-hand side, is always the derivative of mu of x, which is e to the negative x squared times y. And you can verify that by using the product rule. It's equal to, now if I combine the exponents on the right-hand side, we have e to the x squared times e to the negative x squared, so they cancel out. It's just e to the 0, which is 1. Now, our goal is to solve for y, so we're going to go ahead and integrate both sides. So let's go ahead and do that. We're going to integrate both sides with respect to x. And then, of course, the left-hand side is just e to the negative x squared times y. And the right-hand side, we have integral of 1 respect to x. That will just be x. And now we can bring in our integration constant plus c. And finally, we want to go ahead and find the solution by solving for y. So we're going to divide both sides e to the negative x squared. And that will give us y is equal to x over e to the negative x. And I can, sorry, this is x squared. I can make the exponent positive, so that will be x to the e to the positive x squared plus c e to the positive x squared. So there you have your general solution for this problem. Now, if I were to impose an initial condition to this, I will be able to find a particular solution. So we can also do that as well. But for now, this will be the end of it. This is our general solution. All right, so I hope this idea makes sense. So that's it for this video.